Alright, this is 217 notes, overlapping figures, objectives. You'll be able to determine the area of the shaded region of multiple figures. So let's dive right into it. The following is a triangle inside a rectangle. The width of the rectangle is 157 feet long. The height of the rectangle is 71 feet high. The base of the triangle has a length of 137 feet long and a height of 56 feet high. Find the area of the shaded region. So our goal is to find the area of the shaded region. So that means the area of the rectangle minus the area of the triangle, because the triangle is inside that rectangle. And you can see that the rectangle is shaded minus that triangular piece. So that's what we're going to actually do. We're going to first find the area of the rectangle, which is length times width. So 157 times 71. That's going to get us an area of 11,147. We then find the area of a triangle, which is base times height divided by 2. So our base the triangle has a length of 137 times the height of 56, and we divide that by 2, and we get 3,836 feet. Now that we have those, we then subtract them. We take that 11,147 and we subtract 3,836, and the shaded region is 7,311 feet squared. So 7,311 feet squared. So its answer is either E or F. They're both the same. So both of them be marked as correct. Alright, here's our next one. Something got messed up the camera. Slide around though. So the following is a triangle inside of a rectangle. With the width of a rectangle is 92 feet long. And the height of the rectangle is 66 feet high. The base of the triangle has a length of 68 feet long. So the base is 68. And the height is 56 feet high. Find the area of the shaded region. So you find the area of the rectangle, which is length times width. So 92 times 66, which gets you 6,072. So 6,072. You just type that into the calculator. Base, length times width. Then we're going to subtract the triangle. So the area of a triangle formula, put it up right here, is base times height divided by 2. So 68 times 56 divided by 2, that's going to get you 1,904. So 1,904. We're going to subtract that out. When we do that, 6,072 minus 1,904, we're going to get a region of 4,168. Alright, so it doesn't always have to be rectangles and trapezoids. I'm sorry, rectangles and triangles. We can also have a trapezoid. Same concept. You have a rectangular square. We first find the area of a rectangle, which is length times width. Then we're going to subtract the area of that trapezoid, which is base 1 plus base 2 divided by 2 times the height. So area of rectangle, 92 times 66. Well, 92 times 66 gets you 6,072. So 6,072 is the area of a rectangle. We're going to then subtract the trapezoid. So base 1, base 2, well, we get that information from here. The top base of the trapezoid is 47. The bottom base of the trapezoid is 75. So 47 plus 75 divided by 2 times the height of 45 is going to get us 2,745. So 2,745, the area of the trapezoid, that is, area of the rectangle minus the area of the trapezoid will get us the answer we're looking for of this area of the shaded region. which is 3,327. So 3,327. And that's our answer. Right there. Same story here. Just another rectangle. And another trapezoid. Why don't you guys on your own find the area of the shaded region? See if you could do it. Hit the pause button. Alright, now that you hit the unpause button, area of a rectangle 103 times 76, because that's length times width. That gets us a total of 7828. So that's the area of the rectangle. Then we're going to subtract the area of the trapezoid, which is base 1 plus base 2 divided by 2 times the height. So 56 plus 93 divided by 2 multiplied by the height of 63. That's going to get us 4694. $7,828 minus 4,694. We subtract them out to get that shaded region, and we get 3134.5. 31, 34. That don't seem right. I think things got a little bit rounded in the work. So 31, 34. Alright. Another problem, the same concept. So the following is a circle inside of a rectangle. So we got the rectangle again, so the area of a rectangle is length times width. And the area of a circle, pi times radius times radius. So the width of the rectangle is 151, the height is 69, and the radius of the circle is 33 feet. That's all the information we need to find the area of the shaded region. We first find the area of the rectangle, which is 10,419. And we got that number by multiplying length times width, 151 times 69. So that's the area of the rectangle. Then we're going to subtract the area of the circle. So pi times radius. Well, my radius is 33. So 33 times pi gets us 1,089 pi. 1,089 pi. When we subtract those two numbers on the calculator to get that shaded region, you're going to get 6,997.806. And that'll be our answer. Last one. So the following is a circle inside of a rectangle. The width of the rectangle is 157 feet long. The height of the rectangle is 60 feet high. The radius of the circle is 24 feet. Find the area of the shaded region. So to find the area of the shaded rectangle, 157 times 60, because area is length times width. And we're going to get 9420. Because that's what length times width is of this rectangle. Then the area of the circle is pi times radius. So if our radius is 24, it would be 24 times pi, which gets us a total of 576 pi. So 576 pi. I'm going to subtract it because the blue rectangle minus the circle will get us the area of the shaded region. When we do 9,420 minus the 576 times pi, we are going to get 7,610.443 is the area of our shaded region. Alright. Hopefully you get a little bit more comfortable with some overlapping figures. Yes, you could have sometimes 3 or 4 different figures overlapping each other, and you got to work with it as far as addition and subtraction. But you could do it. Classwork 217 CW1, overlapping figures. Your homework is 217 HW1, overlapping figures. If you have any questions, feel free to email me or come to Extra Help. I'll be happy to help you out. Alright, have yourself a good night.